Hello, so in this video, we're looking at composite functions again, but this is a more of an exam style one. So basically, we're given two functions, the f function and this g function, and we're told to solve that f g of x equals x. So this is a little bit weird, but basically we're going to have to do two things. We're going to have to find what f g of x is first, and then we can make that equal to x, and we can solve it. So let's start by finding this function. So I'm just going to take the g function, this whole bit here, and I'm going to plug this into the x value of my f function. So f g of x must be 1 plus, and I'm going to do 4 sets of all of this, plus 4 sets of 2x minus 3 over 2. And that will all be in a bracket. And the entire thing is still in these modulus, so you've got to keep these modulus signs on the edge. Then I can go through and simplify that. So that will give me f g of x equals, and I can have 1 plus this 4 times this 2. Because the 2 is on the bottom, it will cancel out and be a 2 on top. And then I do 2 times 2x is 4x, and 2 times minus 3 is minus 6. And that's all within the modulus. And then we can simplify that a little bit more to find that f g of x equals the modulus of 4x minus 5. And that's it. So we've simplified that right down now. And then for the second part, we need to actually make this equal to x. So that's not too hard. We can just say that 4x minus 5 modulus equals x. And then we can solve it. The tricky thing is whenever you have something within a modulus and you try to solve an equation like this, you need to think, do I take the positive or the negative of all of this bit within the modulus? And sometimes that's hard to tell. So what we often do is we draw this, and we draw this, and then we can see where they intercept. So 4x minus 5, this is going to intercept the y-axis down here at minus 5, and have a gradient of 4, so it's going to be pretty steep. So we can imagine it looking like that. However, it's a modulus. So actually, it's going to come down here, and then it's going to go back up here. It's not going to go below the y-axis, because remember, if it's a modulus, it can't be negative. So we can actually get rid of this part, and what we're left with is just that section. Now, x is basically just like y equals x. So every y value is the equivalent of the x value. So this one would just be a straight line going through the origin, like that. I mean, that's not really perfectly through the origin, but basically like this. And hopefully you can see here that we have 2 points of intersection. We've got this bit here where they intersect, and we've got this bit here. So for this bit of our 4x minus 5, this was the positive version. We didn't take the modulus into account for this bit here, but we did take it into account for this part of the curve. So basically we're going to take the positive and the negative root of this, both of them, or version of them, and make them both equal to x. So if we scroll down, we can first of all take the positive of 4x minus 5 and make that equal to x. And then we can separately take the negative of 4x minus 5 and make that equal to x. And we're going to get 2 different solutions, which will hopefully give us those 2 different coordinates. So for this one, I can take an x on both sides and add 5 to both sides. And I find that x equals 5/3. For this one, I can expand the bracket or apply this minus sign. So I get minus 4x, add 5 equals x. Then we can add 4x to both sides and we get 5 equals 5x. And so 1 equals x. So we've now got 2 x values, which, yeah, it's done. So that solved it. We don't have to find the y values, we don't have to find the coordinates, but we've solved it. We found the x values for which are the same. So by the looks of it, this one here would probably be 5/3 for the x value, and this one here would be 1. And that's all. So to be honest, we didn't really need to draw this. You could have just taken the positive and negative version of this straight away and made them both equal to x. But it's normally just quite nice to draw the diagrams, because then you can see where those solutions will be. So hope that all made sense. If you have any questions, let us know. Do have a go at the MCQs to make sure you got all this stuff, and I'll see you next time.